So today's session is all about statistical testing and experiments. And here is a simple real world problem at Netflix. Again, here is a link to the actual Netflix blog itself. Let me just open this blog link. This is a blog link. Again, Netflix has a very nice series of technical blogs. So this is Netflix tech blog. Again, Netflix is one of those companies which has a phenomenally good blog. So this is a blog from, oh, this is September 22nd. Okay, this is this year, September 22nd. And Netflix, over a period of last few years, has a ton of blogs about A/B tests and what they do. So here they give you the intuition on what the A/B tests are. And they're actual, again, all this is on simulated data, not on real data. One of the things, one of the really interesting features in Netflix that was actually A/B tested was this simple panel of top 10. Okay, this is actually, I'm taking this example from the Netflix tech blog. Okay, just to give you that real world context there. Again, I'll provide you all the links. You can go ahead and read these blogs even after the session is over. Some of them will be slightly technical, some of them are easy to understand. So the question, imagine you're a product manager at Netflix and you got this idea that in each country, can I show the top 10? For example, this is top 10 in Australia today. This is today's top 10. Okay, so I just count which all videos or which all movies are watched by folks in Australia, and I just put the top 10 here. Now the question, imagine if you're a product manager or a business guy at Netflix, your question is this: does showing the top 10 panel, remember showing this panel takes space on Netflix page, right? Again, every inch of space on a web page is real estate, right? So by showing this band of top 10, you're occupying some space in the Netflix homepage. As soon as I log into my Netflix, I start seeing this top 10 in a given country on a given day. Now the question, if I'm a business owner at Netflix, like a product manager, my question is, does showing the top 10 in a country in a day impact time spent on Netflix? That's the question I want to answer. And I want to answer this like a scientist. While I'm a business guy, I believe in data. Companies like Netflix, a lot of internet companies are heavily data driven, and data drives a lot of decisions. I've seen Amazon being a spectacular example of that. Google, you name any of the large tech companies, Uber, they're very, very data driven. And this question, somebody might say, hey, I mean, imagine if you're not using statistics, somebody might say, hey, this is super useful. Why can't we just say, why can't we just roll it out? But what if, while this feature might be sensible, some crazy product manager can come with some crazy idea, and that might actually occupy some space, and it will actually spoil the whole experience for the end customer, right? So for any business decision like this, whether it's at Netflix or any company, somebody was asking this question: what if I work at a small startup? Okay, what sort of experiments can I conduct? For example, for your startup, imagine if you have a web page or if you have a mobile app, right? Suppose there could be some features like this on your web page or mobile app that you want to add. Then your question could be very similar to this: does having this sort of feature be better for your customers and you? Simple question. So the question that somebody is asking here is, the product manager could ask is, does showing this top 10 impact time spent on Netflix? This is an actual product that was A/B tested at Netflix before it was. For those of you who don't know what is A/B tested, don't worry. It went through a series of statistical tests before it was put into production for the whole millions of customers at Netflix. Now, you might say, hey, why are you worried about time spent? Why are you saying, does adding this top 10 increase the time spent? Because if customers are spending more time at Netflix, why do customers come to Netflix? For entertainment. If they're spending more time, that means they're being entertained by the content. They really like the content. If they like the content, more of them will renew their subscriptions, which means more revenue. This is a win-win both for the customer and Netflix, because Netflix is making more revenue, customers are being entertained, and hence they're spending more time. Simple. Very simple logic. I'll give you a simple, slightly different, but an interesting example. Very similar example. This is an example from, any of you have seen YouTube Shorts, right? You might know about YouTube Shorts. These are like your, these are basically short 60-second videos, very similar to your TikTok videos. Okay. So now a question, imagine if you are working at YouTube, right? As a product manager or a business guy, you might say, hey, what if, suppose this is my YouTube app on my phone, right? This is my YouTube app on the phone. And I'm trying to say, hey, in my app, I give you a feed. This is one video that you might like, another video. If you observe on your YouTube app, you get these horizontal bars, right? This whole thing is called the shorts. You get a bunch of shorts almost in your homepage. Just the moment you slide down, you get one shot, then you get another shot. You can keep watching one shot after other shot. Now, the big decision for YouTube is, should we place these shorts? This is the shorts panel, right? Should we place it on the home screen or not? They would have had to do the same thing. Would it increase the time spent on YouTube? Because if you're spending more time on YouTube, YouTube can show more ads to you. Or if you're a YouTube premium customer, you're going to renew your subscription. The more ads or the more subscription revenue, the better it is for YouTube, because more revenue. Simple logic. And it is also more beneficial for the customer, because the customer or the user of YouTube is coming there to be entertained. In more than 90% of the cases, some people go there to learn, but that's a minority, unfortunately. Okay. So a similar thing, this is at Netflix, similar stuff happens at Amazon Prime, any OTT platform, any video streaming platform, or for that matter, any app has the same type of problem. Any mobile app, any web page has to decide whether I should introduce this feature or not. It's a real problem that is solved, to the best of my knowledge, by every internet company, including ours. We keep changing and we keep measuring these things ourselves, right? So simple thing. Now, to solve this in science, so again, remember, all of your tech companies are less than 20 years old, but there is this whole area in science. So all of this was how to actually decide that. The question that I'm trying to answer, let's not forget the context. Does showing top 10 impact time spent on Netflix? This is a question that we want to answer. Now, for that, we will take a concept in statistics, which again, this is used in whole of science, engineering, etc. But the concept itself comes from core stats, classical statistics, very powerful concept. This concept is sometimes referred to as randomized controlled trials, or randomized trials, RCT for short. Again, this terminology of randomized trials or randomized controlled trials is often used in medicine. For example, if you read any if you see any major vaccine, whether it's Covaxin, Covishield, Pfizer, or any medicine for that matter, every medicine, before it gets authorized to be sold in any country, it has to go through a randomized controlled trial. This is a terminology that's often used in science and medicine, right? I'll give you another very interesting example. The recent Nobel laureates, right? Esther Duflo and Banerjee from India, right? Who won the economics Nobel Prize, I think last year or the year before that. What they did was, they literally, if you see some of their work, I'm a big fan of their work in education, especially in rural India and rural Africa. They have actually conducted randomized controlled trials on social problems, whether it's about access to education, what works, right? So their economics Nobel Prize is because they conducted actual randomized controlled trials in social sciences, especially in the fields of education, healthcare, income, and things like that. Very, very interesting piece of work. Okay. Again, Esther Duflo and Professor Banerjee are professors at MIT. Professor Banerjee is an Indian, as you might know from his name. And they literally did this, right? So A/B tests is just a different name, because remember, these statistical tests are used in lots of fields. When they're used in medicine or scientific research, they're called as RCTs, or randomized controlled trials. The internet companies call them as A/B tests. When I was working at Yahoo, they used to call them as bucket tests. I've seen some companies also call them as split run tests. They all mean the same thing. Okay, just different contexts, different names, but intuitively they are one and the same. So we will try to answer this question about Netflix, whether showing these top 10 is helpful or not. We will try to answer that simply using A/B tests, because this is the scientifically rigorous mechanism that we have available. Okay, again, this diagram itself has been taken from the Netflix blog. I'll provide the link to you also. So the way it works is very simple, elegant, easy to understand. You can explain this even to a 10th class kid. Suppose these are all the Netflix customers, tons of customers, right? All these customers are randomly split into two groups. The first group is called as version A, also called as control group. Let's assume at this point of time, the status quo. Let's understand that. The status quo, which means when we want to do this experiment, there is no top 10. There is no top 10 banner that's there on the Netflix page. Okay, we will randomly split them into two groups. One group is called A, another group is called B. Group A is called control, where what we maintain is status quo, which means no top 10 bar. There is no top 10 bar here, right? No top 10 bar. The second group, called as group B, sometimes called as test group, or also often referred to as treatment group, right? So A/B tests are also sometimes called as controlled treatment experiments. Controlled treatment experiments. So in the control group, we don't give anything. We just have the status quo. In the treatment or the test group, we place, let's say, top 10 here. Let's assume we place that, right? We are randomly splitting the customers who visit the whole Netflix page into two groups. And then we will scientifically measure and use statistics to determine whether it's useful or not. Cool. Now comes the fun part, right? So let's assume this is all the users of Netflix, some millions of users. You randomly split them into two groups, control and treatment. Very simple. Suppose you have a user in the control group. Okay, so for this user, you're measuring this variable. Let me explain what this variable is. This variable is X superscript C subscript I. Let's assume this is some user I or customer I. For the ith customer who belongs to the control group, I'm going to measure the time spent on Netflix in this session. Again, when I say in this session, at this point of time, suppose I gave him a home page without any top 10, how much time is he spending? Similarly, when you're randomly splitting, you have a bunch of customers or users, right? Some users randomly go to control, some users go to treatment. So in the treatment, again, in the treatment, what happens? You have the top 10 panel here. In the control, you don't have the top 10 panel. Again, take each user I here, and for each user, you will measure time spent by the ith user in the treatment. So your XI basically says time spent on Netflix by user I. This user could belong to control or treatment. This superscript C we are using to determine that this user belongs to control. This T we are going to use to say that this user belongs to treatment. Till now, very simple stuff. Okay, nothing very fancy. Again, these are called as randomized controlled trials. Why is that called randomized? Because given all the users, we are randomly splitting them. Controlled trials, because we have a control population or control group where we are not changing anything. For these people, we are just giving the same website. For these people, we are placing the top 10, right? So there are two groups now. Okay, cool. Okay, now given these two, how do we continue now? Now, there is always, remember, whenever you're doing any real world experiment like this, there is always a cost of experimentation. For example, okay, let's take a simple example. What if, okay, since we're talking about Netflix, right? Let me give you a slightly more interesting example, more challenging example. Suppose these are all the patients or all the people, let's say. So let's say I'll give you a real world example that's happening right now. Take all kids in the age of 2 to 18, right, in India, in 2 to 18 years of age, all the kids, right? You create a random sample of, let's say, some 1,000 kids and another sample of 1,000 kids. This is an actual experiment that's happening across the world for COVID vaccine now, for young kids, right? So these 1,000 people that you have, they are your control group, which means no vaccine is given. No vaccine, right? Then another 1,000, you give, these are your treatment, which means you give them some vaccine that you're experimenting now, right? Now, over a period of time, maybe some 90 days or so, you track how many people or how many kids in the control group were infected by COVID and how severe was it. Similarly, for 90 days or so, you track these 1,000 kids who were given vaccine. If most of the kids who were given vaccine did not get infected, you say the vaccine is good. Also remember that the kids who have been given vaccine should also not have side effects. Now here, in your control treatment experiment, there is a big problem. These 1,000 kids to whom you're giving a vaccine, imagine the worst case always. There is always a cost. There is always a human cost in this case. These are kids, for God's sake. Imagine if your vaccine is not designed properly and these 1,000 kids have some side effect. I mean, the cost of, you might say, hey, these are only 1,000 kids. No, these are 1,000 kids, right? So the cost of doing a bad treatment can be very, very large. That's very, very important. That's why for most vaccine studies, you never see 1,000 people doing in the first go. It starts much smaller sample sizes. This is called the size of a sample, because from the whole universe of millions of kids in India, or hundreds of millions of kids, we're only taking a sample of 1,000 kids and give them no vaccine. Other 1,000 kids, give them a vaccine. So in the real world, it's very important to remember that there is a cost associated. There is a human cost. There is sometimes monetary cost associated with experimentation, right? What if this vaccine is bad for kids? I mean, it'll be a nightmare. Similarly, let's look at it in the Netflix experiment. Imagine, I want to do some crazy experiments. Okay, the top 10 seems like a very nice idea. But imagine somebody says that, hey, okay, let me tell you a control treatment setup, right? If somebody comes and says, hey, let's remove the sign up button. Somebody says, let's assume somebody's sign in button. Let's assume somebody says, let's remove the whole damn sign in button only from the whole website. Okay, then your treatment could perform very, very bad, which means customers to whom you don't, again, the treatment, any experiment can be conducted. The moment you have an experimentation setup and your company says, we will do scientific experiments before we make business decisions, some guy will come up with this crazy idea and he'll say, why not test it? How do you know that this won't work, right? So in such a case, maybe for, again, if I randomize everything, for example, take the case of Netflix. Suppose I have some 100 million customers. We write million as MM because 1 M is 1,000 in Roman numericals. MM 1,000 to 1,000 is a million. Suppose if I randomly split 50% and 50%, 50 million users are in my control, 50 million users are in my treatment. If my treatment, where I remove sign up button, let's say that's an experiment. I'm just changing the experiment just to show you the cost of experimentation. Then you have really pissed off 50% of your users, and that's terrible. That's terrible, right? So treatments could be terrible, and hence they could have monetary cost. You might lose customers. It might have health impact, whatever it is. So this is not to be taken lightly. Okay. So now what you might say here is, imagine you're at Netflix. You say, hey, I don't want to touch all the millions of customers. I'll take a pool of 1,000 random customers. So from the 100 million customers we have, I will randomly take some 10,000 customers. Or let's assume I'm a small website. I only have 10,000 customers. I will break my control, 9,000 customers in control and only 1,000 in my treatment. Okay, imagine I'm a small startup, not Netflix anymore. Again, I'm trying to give you various ways of thinking about it. In this case, what happens is, because only 1% of my customers are part of treatment. Again, control is status quo. This is already there. Okay, let me give you a slightly different example here, just to contextualize this 10,000. Suppose we have our website, right? Suppose we want to change the colors of our website completely. Okay, right now we have black and yellow and white colors typically. That's a status quo. Somebody comes and says, hey, please put pink and some crazy colors, violet and all that. I'm like, okay, let's do a simple experiment, right? So I say, hey, my treatment is 1,000 people. So only 1% of my users are seeing this crazy website. So even if it is terrible, even if customers hate it, the impact will be small, because some of them will email us and say, hey, your colors looks really bad, right? The impact is small because 90, sorry, this is not, I'm sorry. This is not 1%. This is 10%. I'm sorry. This is 1,000 out of 10,000, right? I'm sorry. So only 10% of my customers have seen this terrible web page. So the impact is small. That's good. But here comes in another scenario. What if I want minimal impact? Then I could split my control and treatment into 99% versus 1%. So always remember, whenever you want to do experiments like this, if you think that the treatment could be very bad, in the worst case, always prepare for the worst case. You should do this specifically in medicine, okay, or where you have a crazy idea. Don't split all of your customers into 50-50. Split them randomly. You're going to still split them randomly, but 99% of your users will go to control, where they see the status quo. Only 1% will see your treatment. Here, the impact is going to be minimal. But my sample size, which means the number of customers who are seeing this new website, is just 100, very small. Can I come to statistical conclusions using just a small data from only 100 customers? That's an interesting, an important question if you think about it, right?